On any given night, if it's clear or you're away from the city lights, you should be able to see about 5 what we call just sporadic or random meteors per hour. Now, there are other times when we see more meteors, and even through light polluted Calgary. These two pictures on the left are taken from the city of Calgary, where there's lots of light. You can see the glow on the horizon there. And if you see, so there are times during the year we get to pass through streams of debris, and this will produce a shower. And I'll only mention a couple of them. We can spend a whole evening talking about all the various showers, but the two really popular ones I think you hear a lot about in the media are the Perseids, and it's in August, so it's students are out of school, families are out camping, they're out in the dark skies, a perfect time to be looking up and watching, say, the annual Perseid meteor shower. And then there's the Geminids, which are just going to be happening here later this in a couple of days on peaking around December 13th, 14th. I think they're even better than the Perseids, but people are not as keen to go out and sit outside in December, as it's a lot cooler. So, but if you do get that chance, you may see some meteors in the coming days if you have clear skies. Now, meteor showers, their primary source are cometary bodies. And if you can see my notes, there's a little asterisk by comets because there's one particular shower that is, seems to be, there's some debate on what its source is. But these particles from these comets get, they sort of fall off the comet each time it goes around the sun. So every time a comet goes around the sun, and let's focus on the Perseids, Comet Swift-Tuttle is in a 133-year orbit, and it comes around every time it comes by the sun. It's going to lose more material as the frozen gases sublimate into a gas and releases more dust and gravel-sized particles. And every August, we pass through that stream. And I can display this with an animation here. There's a really good website called meteorshowers.org. And this is a view, imagine you're sort of above the solar system. We're looking, I think I can turn my cursor, yeah, my cursor is here. I'm going to turn it into a laser pointer. Here we go. So this is the orbit of Saturn, Jupiter. There's the inner planets, Mars, Earth, Venus, and Mercury all inside here. And we can see this is the orbit of Comet Swift-Tuttle and the debris train that it leaves behind. And we're going to start this animation here. And you can see how this, every month, and this is cool about the website, you can actually pick your meteor shower and you get the dates here. We're advancing about a month per second here. And let's zoom in a bit and we'll start the animation again. And you can see we're following the trail in, and every August, so right about, boom, there, we're going through that blue dot that's going around, if you can see it on your screens, is passing through the debris train. And that's why we see a meteor shower every August, because we're passing through the debris from Comet Swift-Tuttle. Now, I mentioned the Geminids are quite a bit different. So we're going to back out again. Here's the orbit of Saturn again. So we're out, say around Uranus looking in, but look at where all this debris for the object that's producing the debris for the Geminids. This object's been given a name 3200 Phaethon, and it looks more like an asteroid than a comet, because here's Jupiter, there's Mars, that other orbit, the orange one there, well, that's yellow-orange, but most of this debris goes out to about the asteroid belt. Let's zoom in again and look at this. So we're looking at this debris train or trail. It's more asteroid-like, and that's why we're not sure what 3200 Phaethon is. Is it really an asteroid that kind of acts like a comet? Is it a comet that's kind of been exhausted and it's in a more cometary or asteroid orbit? So we're not sure what the source exactly is, but this is a very interesting shower that's coming up in a few days. And like I said, it produces typically more meteors than the Perseid. So I hope you do get some clear skies and go take a look outside and try to find some Geminids coming up here in a few days. So the peak dates, December 13th, 14th, coming up fairly soon. Now, there's another way to see meteors. If you're not, you're not the kind of person that wants to sit outside on every clear night in a lawn chair looking up, well, you can set up a camera system. I've started since the mid-90s of just pointing a video camera out my dining room window, at every night and just trying to record something. And surprisingly, I actually caught a fireball one time. It was just amazing. So I mentioned this to Dr. Alan Hildebrand at the University of Calgary. And he says, I have some old Sandia National Laboratory all-sky cameras. So we mounted it out in the backyard, and this camera system worked with, it had a low light video camera in the tube pointing down to this mirror, sort of semicircle or half of a mirror ball, and it looked at the whole sky. And surprisingly, it worked very well. The only downside is every night I had to change the videotapes. It taped onto VHS tapes, which you can imagine, when I went on holidays, the system was down because no one was there to change the VHS tapes. But it worked very well. It was a good system, and we recorded quite a few bright meteors and fireballs with it. Just recently, in the last few weeks, thanks to the meteor physics group at the University of Western Ontario and the help of Mike Mazur and Denny Fida, we got a new camera now working in the backyard. It's more high tech. I don't have to change VHS tapes. It all goes into the cloud. It has some smart AI intelligence there to sort of pick out changes in pixels. So we got some new systems, and this is a sample of what it looks like over one night here. So when the clouds, this is November 20th, you can see the stars rotating there, I think across by the house. This is the Big Dipper over here. There's the handle, there's the bowl, and it arcs down to Arcturus rising. You're going to see Venus rising right down here. There's Venus. And of course, the clouds come in again. So it works really quite well. It's a nice system. It's fairly sensitive even in a light polluted city. I don't know if you noticed in that clip, but there were a few meteors. There's one over here by the tree. You can see it flash. I'll just replay it there. And then there was another one about the 3 o'clock position right there. So it works very well, and we're hoping to catch, again, meteors are something that I'm sure the academics really like, but we're looking for the fireballs. We're trying to find meteorites here, rocks from space, right? That's our goal. Now let's, so now you set up a network of these all sky cameras. They're set up around the prairies across Canada, and now you're waiting for the big event. So just a few years ago, September 4th, 2017, this is a camera at Sunshine Meadows in Alberta. We had a very bad summer that year for forest fires, and the smoke in the valleys were horrible. That's the moon glowing up above there in the lake, but this is what happened in the middle of the night. We'll play it one more time here. A large fireball came in through the atmosphere and dropped meteorites. And this is the chasing part here. I know people, I've had eyewitness say, I saw the fireball and I'm sure there's meteorites in my neighbor's yard, just, a few doors down. Well, really these things are hundreds of kilometers away, and it takes a lot of work to narrow down the site. So here I am with Dr. Hildebrand and one of his assistants, Lincoln Hanton, here on the roof of College of the Rockies at Cranbrook, BC. And we're just looking at their all-sky camera and using a theodolite. This theodolite was borrowed from Jeff Zambori, a Calgary Center member here of the RASC. This is a beautiful machine, and we were able to take some sightings to get a better idea of the start point and the end point, which helps calculate an orbit. And also, to once we get the end point, we can take run it through some software, which is called dark flight, to see where those fragments may have landed. And lo and behold, a few weeks later, the University of Calgary, this is one of Dr. Hildebrand's grad students, Fabio here, holding up some of the meteorites that they found from that fireball. So that's a great success story, chasing the shooting stars to find some rocks from outer space. But we're not always that successful. Here's one recorded on July 2014. We'll let it run here a bit. And again, as always seems, these fireballs are not to the east where the prairies are. They're always to the west where the mountains are. And it's a lot harder finding rocks in the mountains, let me tell you. So there's a fireball, and we never did find, or have not yet found, any meteorites associated with that event. Now we're going to go back even further in time, because this was a very big event where a 10-ton meteor entered our atmosphere, or a meteoroid, I guess, entered our atmosphere and produced a fireball. So we're going, look at the time, 5:25, prime time. Everyone's coming home from work. We had exceptionally clear weather right across the prairies. And if you look just below the 25 there, or now 26, you'll see a glow. Boom, right there. We're going to zoom in, look at it one more time. Might not look like much, but that's a 10-ton rock entering our atmosphere and exploding along the Alberta-Saskatchewan border. Okay, so now we go, so we got an all sky camera. Now let's look at some security cameras on the Saskatchewan side. And this is what they saw. So a beautiful fireball event. And again, Dr. Hildebrand with his grad students, we start collecting as much data as possible, security cameras, dash cams, any all sky cameras. And you start, taking the azimuths, taking the bearings, and you eventually come to a place where you can apply software, which is called dark flight. And there's a specialist, Elizabeth Silber, out of Western University, who's a guru at this. She will run the calculations and tell you where the search area is. And this ended up being a little north of Marsden, Saskatchewan, in a place that has been named Buzzard Coulee. And only about a week, so the fireball was November 20th. 7 days later, Dr. Hildebrand and his grad student, Ellen Milley, were driving up and down the roads looking for meteorites, and they happened to see this black spot on a pond just off the road. And they wandered down onto the pond, and sure enough, it was the first piece of the Buzzard Coulee fall. So what an amazing discovery. That was quick, only a week after landing. So this, this called for a lot of volunteers, RASC members, local people from, the area, from the cities. We drove out and spent a lot of time walking the fields. It's like a CSI investigation. There's, say a half a dozen or, 10 people walking about a meter apart in a line with sticks with rare earth magnets looking for these rocks from outer space. This carried on into the summer and just more searching. I think you could probably go there now and still find more meteorites, but they do belong to the landowner, and the university cut a deal, of course, to have permission to walk the fields. But just walking the land, you'll see these rocks that have fallen. I mean, how cool is this? Like just, a few months ago, this rock was in outer space, and here it is now landing on our Earth on this farmer's field here in Saskatchewan. And this is one here, another one. I mean, they were everywhere. That's a big one. That's about a 13 kilogram piece right there. So let's go now to the year 2013. And there was a rather big event that occurred on the other side of the world here. So February the 15th. Now, I know they're going to call, the animation calls this a meteor. This was an asteroid. This was about 20 meters in size. I mentioned the object that fell in Buzzard Coulee was 10 tons. This is 10,000 tons entering the atmosphere. Can you imagine driving to work and your dash cam picks up this fireball? Well, it's not a fire. It's a super bolide is what they call it. Here's another. You just pulled up to the red light. You're waiting for the light to turn green. And this comes across from left to right across your window as you're sitting at the red light. Unbelievable. It's brighter than the sun. Yeah, people casually walking to work kind of thing, like, wow, what was that? Like, it was incredible. So this was the Chelyabinsk, of course, super bolide that occurred here in 2013. And it came in on such a shallow angle, it eventually exploded at about 20 kilometers, releasing a 500 tons worth of energy. And it shattered windows everywhere. It was just tremendous. So this is a YouTube compilation here that shows the shock wave that hit Chelyabinsk in about 6 cities all around there. The shock wave took about 2 to 3 minutes to reach the ground. So, people are at the windows looking outside, and then the shock wave hit, just blowing out windows. Over 1,500 people had to be taken to the hospital for, some injuries. Usually, most of it was just blowing glass. Watch this door at the top. I mean, incredible, the power. I mean, can you imagine what you must have been thinking? We're under attack or something. It's just crazy. So here's the fireball going over, basically saturates the CCD, and then they fast forward about 2 minutes, and wait for it. You'll see the windows just get blown out. there. So yeah, that was something that maybe once every century we get to experience here firsthand, like right over a city. And this is an LL ordinary chondrite, so it's low in iron, low in metal content, but it's interesting because I'll bring this, remember that LL chondrite. Now, just most recently, just this past summer, there was another fireball, July 23rd. Predictions looked like the fragments landed around the Fairmont Hot Springs area. Not too bad of a spot to go searching. Unfortunately, it's COVID time, so not the best time to be going to a resort. But Dr. Hildebrand gave me a map here, and I went with a good friend, Toonie Fink, and we were looking at this area right here on the west side of the lake and looking for 50-gram meteorites about the size of a golf ball. And well, we're not always successful. I mean, we did a lot of walking. And one thing about meteorite hunting, you get lots of fresh air, and we got over 25,000 steps in that day. So it really helps keep you in shape. The map on the left is just some of our grid searching. This is just like a couple hours in an afternoon. You really get to see the countryside. And it's beautiful to be out in the mountains looking for meteorites. So that's chasing natural shooting stars. But you know, there's artificial shooting stars or meteors or fireballs. And these are some, the first four I've seen personally. I've seen a shuttle re-enter over Calgary in 1996, phenomenal. I've seen a daytime fireball produced by Genesis, the spacecraft or sample return canister that was bringing back samples of the sun. There was stardust that went through a comet tail, bringing back samples. That was a night one in January of 2006. And then the one we're going to focus on a bit today is Hayabusa in June of 2010, 10 years ago. Hayabusa 2, I was supposed to be down in Australia, but COVID, and I'm here in Calgary. So we did not get to see that in person, but it looked like a really smooth and nice reentry. Something to put into your calendars if you want to see an artificial reentry or shooting star is planned to go to Utah around September 24th, 2023.
To go to Utah.
So that's a good time to see OSIRIS-REx come back. And of course, there's these commercial crew capsules now that I would think they'd make quite a fireball because they're really okay. Am I? All right. Can you hear me? Everyone can hear me?
You're good.
Okay. All right. So we're going to focus on Hayabusa, June 13th, 2010. We're going to go back in time because this was a great reentry to see. This mission was by the Japanese. They were out to see a small asteroid called Itokawa, launched in the early 2000s. It arrived at the asteroid in good fashion, but then it suffered several mechanical and instrumental failures. It did collect two samples, sort of, but it had troubles. The spacecraft lost its chemical propulsion. It lost two control moment gyros, or these wheels that spin around that help orient it. Even its ion propulsion system. But luckily they had two sets of it. And, I give these engineers, they all deserve a gold medal because they were able to take working components from each system and kind of rewire it from Earth. You got to think this asteroid's millions of kilometers out, and they're sending commands to kind of rejigger how this, how the components work together, and they got it working again. So eventually this mission came back to Earth over 2 years late. And this, so it's bringing back, it collected samples off the asteroid, it's bringing them back to Earth, and it's going to land in Australia. So Dr. Hildebrand and I thought this is going to be quite a scene because the main spacecraft, which they call main spacecraft bus, or main bus, was not going to be diverted. Normally, what you would do is you would release the sample return canister and then fire engines to avoid burning up in the atmosphere, saving the main spacecraft for another mission. Well, because they were well beyond the design date of the batteries, they wanted to keep the capsule, which had to fire a parachute, have a beacon to find the capsule in the Australian outback. They wanted to keep it attached to the main spacecraft bus for as long as possible. So they were going to sacrifice the main spacecraft. And this is what it looked like to us in real life. So you can hear the excitement in our voices. Okay, we should be really close. There it is. There it is. It's brightening up. Got a tail. Oh, it's fragmenting. Yes. Spectacular. It's got a trail. I lost it, yeah. Spectacular. And it was. That was the one of the most incredible fireballs. Again, artificial. It was not natural. Now, where else can you go? I mean, you know the time, the date, the mass, the velocity. I mean, what a great way to study fireballs is to go plant yourself underneath the entry point of a returning spacecraft. So this is a fisheye lens of the event. You can see the southern Milky Way stretching overhead. There's the coal sack over there to the left. And Alan was firing some other pictures here on just a wide angle lens. There's the main spacecraft breaking up. This second street below it is the SRC, the sample return capsule, streaking across the sky, turning red, and eventually disappearing and beginning its dark flight as it comes down with a parachute. And it was picked up later. These are some frames of the video of the main spacecraft breaking up the sample return capsule right underneath, and eventually done. NASA had a plane chasing this, and their video is way better. You got to think this is 2010. You know, CCD, home camera. I don't have fancy equipment. This is like the home video camera that I used to videotape my kids' birthday parties and all that. So this wasn't research quality. This is what NASA got. Anyways, the mission ended in success. The canister returned safe to Earth. And once returned to Japan, they opened it up. And even though the sampling mechanism did not work properly, the Japanese system uses a projectile or a bullet that they fire into the surface of the asteroid to kick up the regolith that would be collected by this horn, this device to collect the regolith. And unfortunately, on both attempts to collect samples, it did not fire. There was like some safety. I believe the story I heard was that there was some software that there was a safety kind of line of code in there that someone didn't take off, and well, the gun didn't fire basically. But these pieces, they actually had over 1,000 dust particles from the asteroid, and interestingly, very similar in composition to Chelyabinsk, which I thought I'd just close that story. So another ordinary chondrite. Very, very cool. So you must have been watching the news just recently, Hayabusa 2. So 4 years after the return of Hayabusa 1, they launched Hayabusa 2, and they had everything on this mission. They had landers and rovers, and they had a cannon. I mean, it was like it was the best mission. Just so cool. Like the picture in the lower right here, this is the surface of the asteroid. They dropped, a lander with a camera to actually take pictures of the surface of the asteroid. I mean, how cool is that? And I said they brought a cannon. They did 2 sample runs. The first one was to just go to the regolith and collect a sample and then pull back. The second one, they said, well, let's get below the surface. How are we going to do that? We don't have a drill or something. Well, let's use a cannon. So this is the test of the cannon here on Earth. So that's what they put on to Hayabusa 2. They released the cannon and a second camera to kind of watch the explosion and the detonation and the impact so they know where to go back and then sample this new crater that would hopefully blast away the surface regolith and look deeper down. So very, very cool. And this is the picture of the impact of that projectile. This is a copper projectile that they fired into the asteroid. And this is a sped up, 10 times sped up version of the collection of those samples. So here, that's the collection horn, the black silhouette near the top of the frame there, coming down towards the surface there. It'll fire its projectile, kick up a bunch of loose regolith, disturb the surface. And because of the very little gravity, things are flying everywhere. And hopefully, when they open up the canister here very shortly, they'll find lots of pieces of asteroid Ryugu inside. And as I mentioned, they did everything as they planned. They approached the Earth on a collision, basically trajectory, released the capsule, and then they did their diversion maneuver. They fired their thrusters to avoid hitting the Earth and doing sort of the same fireball that we saw back in 2010, and the capsule re-entered. And this is a picture stretching from right across the sky of the Hayabusa 2 fireball. Now there's another artificial reentry that's coming up, as I mentioned, in September of 2023, OSIRIS-REx. This is the spacecraft in the clean room at Cape Canaveral. And in the briefing, I still remember this to the day, we're giving a safety brief before they go in, and they look us all in the eye and saying, and if for goodness sakes, if you have to sneeze, look away from the spacecraft, because we're in a room here that had missions like Stardust, Genesis, the Mir rovers, the Mars rover. Like, this room is hallowed ground, and it's an ultra clean room. And the last thing they want is some, guy like me from Canada sneezing all over their spacecraft. So it was just so funny when they like, for goodness, they look away from the spacecraft. But the launch was spectacular on September 8th. I remember the day very well because I remembered 50 years to the date was the first episode of Star Trek on TV. So that was great. Mantrap was the episode. I remember that very clearly as a little guy going, wow, that's quite a series. Anyways, OSIRIS-REx. Now, the name OSIRIS-REx, I should actually clarify that. OSIRIS-REx is origin, spectral interpretation, resource identification, security, and regolith explorer. I mean, that's a mouthful. And yet, that's the mission that is launched, and you can tell what its goals are. So asteroid Bennu is about 500 meters across. Rotates in a little over 4 hours in a 1.2 orbital period around the sun, and it's a carbonaceous chondrite. So both Hayabusa 2 and OSIRIS-REx have gone to carbonaceous, very primitive, asteroids. Very good representation of the early solar system. And Canada is involved as we provided a picture or an instrument, of what's called OLA, the OSIRIS-REx Laser Altimeter. And because we've supplied this instrument, we're going to get 4% of whatever comes back. So that's exciting. And Japan will get, I think, 0.5% because we're trading samples with them with their Hayabusa 2 samples. That's very cool. And the OLA was able to use a LiDAR mode. So it's a laser that not only could be used for altimetry, it can also be used to make a very good LiDAR map. So LiDAR, light detection and ranging, they have this surface topography down to about, 3 centimeters or something, just ridiculously good accuracy. So on October 20th, the spacecraft was commanded, after rehearsal in August, was commanded to descend very slowly to the surface of asteroid Bennu. And the surface collection device looks like a air filter for a car or truck. It's about that size. It has a mesh on the outside, and it uses nitrogen to agitate the surface. And so I'm holding it there. Let's give you a sample of the size. And this is a video from Lockheed Martin showing how the instrument works. So this is its stow position on the spacecraft. It will be unfolded. There's a tube that runs to the nitrogen bottles that will blow out nitrogen through the, it's called TAGSAM, touch and go sample mechanism. And when it hits the surface, it's like a plunger device. It releases the nitrogen and then pulls away. This is another test. And you lift up the ring and beautiful asteroid regolith, we hope. So that's what was supposed to happen. This is what actually happened on October 20th. So this is a little GIF, a little time lapse here of the spacecraft. This is sped up, of course. The spacecraft was descending at about 4 centimeters per second and did a touch and go and pulled away. Now I'm going to run this again a bit slower. This spacecraft, well, first of all, the sample mechanism needs to be flushed to the surface. And when they were coming down, they saw there was a rock in the way. And this spacecraft literally crushed the rock and carried on. Even just on first contact, it sunk about 10 centimeters. And then it proceeded for the next 6 seconds to continue moving forward. There was no pushback. They just continued blowing the nitrogen and continuing 4 centimeters per second to a point where they basically had to fire the thrusters to pull back. And it took 3 seconds to stop the forward motion. So when you do all the math, it looks like they penetrated about 48 centimeters into, that's like half a meter into the asteroid. Unbelievable. So it's going to be very cool to see what they bring back. So a few days after, they took a picture of the sample collection mechanism here, and they were losing sample. I mean, it was so full. Even the mylar flaps that are supposed to hold the sample in were sort of breached open because of large samples. They had to command an early stow. And this is a few photos here showing the sample collection device being put into the return capsule and sealed for its journey home, which will begin in March of 2021. And as I mentioned, you have to circle the date, September 24, 2023. That's when it comes home to Utah. Now, asteroids, of course, have significance to us because I don't know if we'd be here. 64, 65 million years ago, a big asteroid took out the dinosaurs. And if it wasn't for the end of the dinosaurs, who knows if mammals would have, come out to be on top of the scale, evolutionary scale. But you can see meteors, you can see evidence of large impacts. You can go to Arizona to see Meteor Crater or Barringer Crater, about 1.2 kilometers across. Beneath the surface, we know the dinosaurs, at least there's always some controversy, but there's a large impact, and a mass extinction event occurred about 64 million years ago that created a huge crater over, I think, 200 kilometers across along the Yucatan Peninsula, the Chicxulub crater. Then, of course, through my own work as a geologist, I was involved in drilling the Steen River impact crater, which is the largest buried impact crater in the Western Canadian Sedimentary Basin. And this is a gravity map. We removed the central uplift because it was sort of distorting the rim, which was our target. And very cool working on that project with people like Dr. Hildebrand, Mike Mazur, and others. It was a fascinating experience drilling beneath the surface, and there's others. I mean, this is just one of many beneath our feet. And eventually mining, our civilization will eventually move out to the planets, and asteroids are great resources. We know there's metals, there's hydrous minerals. If you can get water, water can be broken down to hydrogen for rocket fuel, oxygen to breathe. Water can be purified to drink. So, asteroids could be a huge resource in the future. And there's always that big question is, how did the Earth form? And as I mentioned early on, we don't have those old rocks here on our planet, we have to look to the asteroid belt and meteorites that give us some clues as to how it formed. And these asteroids that were just explored by Hayabusa 2 and OSIRIS-REx, these carbonaceous, these primitive carbonaceous chondrites will give us an answer to, what is the composition of that water that's locked into those phyllosilicates. And there's organic matter on these asteroids. Did some of this organic matter help start life itself on our planet? So there's some big questions that I hope that will be answered when these samples come back to Earth. So make that effort. If there's a clear night and there's a meteor shower, pull out that lawn chair, a warm sleeping bag, and maybe a thermos of hot chocolate and go outside, because you just never know what you might see out there. And if you see a fireball, please report it. If you go to the America Meteor Society, they do have a form. And, we'd like to know about these so we can check our cameras. Fireball, the first thing you should do, just some tips here, is pull out your cell phone, if you have a phone, or your watch, and get the time, because time is so important for when we're checking all our data records. And then try to remember, where were you? Were you driving? Were you standing? Like, where were you physically? Because then that gives us some information at what direction to look. Because then you're going to mark down, maybe on your phone notes or a piece of paper and a pen, what direction was that fireball traveling? What was the angle? Was it steep? Was it shallow? Give us some information. How long was that fireball? Did you see any flashes or bursts of light? Was there color? Was there a remnant dust trail? And did you hear sound? Because several minutes later, you might hear a sonic boom. Anyways, put this all into the report, and that's great. And, if you do know anyone that's looking for meteorites, go searching, volunteer. It's a great opportunity to get outside, get some fresh air, and it's COVID safe because you're working outside, and it's all good. So now for something, we're going to change total direction here now. We're going to do something completely different. We're going to talk about chasing something else. And this is now the shadow of the moon. So we want to go and stand in the shadow of the moon. And this is, if you've never done it, and I'm hoping everyone that's online has seen a total solar eclipse, but if you haven't, please put this on your bucket list, because this is something you have to experience. First of all, we're dealing with this incredible cosmic coincidence. We're dealing with the sun and the moon. The sun is about 400 times larger than our moon, but our moon is about 400 times closer. So the apparent size of them, they both appear to be about a half a degree in size, an angular size in the sky. I mean, great. What is the chance? It's wonderful that we have this opportunity. And there's different types of solar eclipses, of course. If you don't quite cover the full surface of the sun, we have a partial eclipse. If you do get the moon right over top and it's big enough to cover it all, we have a total eclipse. If the moon is at its farthest point from the Earth, it's smaller in size, it will not completely cover the sun. So we get an annular eclipse. So we have this annular ring of, ring of fire, really, around the sun, which is quite different. And then there's a hybrid eclipse, an eclipse that morphs from an annular to a total. So it changes its type of eclipse during its path. I've only seen one of those, and truly it is spectacular. So let's watch this NASA animation. I'm going to have a sip of tea here. So a total solar eclipse is when the moon covers the sun. If it doesn't completely cover the sun, we have a partial eclipse. A lunar eclipse occurs when the moon passes through the Earth's shadow. And that can be visible from anyone on the dark side of the Earth that's looking up at the moon. So it's much more common to see a lunar eclipse. And if you want to know what name belongs with what, well, a solar eclipse, the sun gets darker, the moon gets darker with a lunar eclipse. But what I want to focus on today are total solar eclipses, because this is where you are trying to position yourself in the precise point that you're standing in the shadow of the moon. And this is the last eclipse that I was able to witness. It was in August of 2017, and we were in Idaho. And I'm hoping a lot of people made the effort to see this one, because this one for Canadians wasn't too hard to get to. But COVID now would have been a lot more challenging, but at that time it was all good. So we're standing in the shadow of the moon. Now there's two parts of the shadow. There's the umbra, which is the darker central portion, and then the penumbra. But think of the geometry. The moon is about 400,000 kilometers away, and it's projecting this tiny shadow that might be 200 kilometers across, and you're trying to stand in the shadow of the moon. Just it's amazing to think that. And I want to describe, this was my first eclipse. My pictures are still slides. I haven't scanned them yet, but it was a freezing morning, February 26, 1979. I skipped classes. Yes, I skipped school. I'm admitting it now. It was like a Monday or Tuesday, something like that, the 26th. And my friends from university and the RASC, Hans Thader, Bill Crosney, Luba Crevet, we all drove out to Hecla Island, and we stayed out there over the night. It was cloudy, it was horrible. And, I've seen pictures. I've been an astronomy, guy from the get-go, and I've seen pictures in a book, and I was not prepared for how it affected me. I mean, it truly was something that you just don't see, you experience a total solar eclipse. I mean, the sky darkening, when it is eclipsed, the Bailey's beads, the diamond ring, the 360-degree sunset glow, it brings out some visceral, emotions that, something's not right. Something is just not right. So all these maps are courtesy of Andrew Lowe. He has a great website of, centuries worth of eclipse information. So if you're looking for something that you've seen or missed, check out Andrew's website. And thank you, Andrew, for letting me use these slides. So this affected me so much that I started seeing more eclipses. I just could not imagine, not seeing this again, because it was over 2 minutes in Winnipeg, the one, Hecla Island in Manitoba. It seemed like 10 seconds. I mean, time just seemed to have flashed by. And to see more of them, and it doesn't get any better, they still flash by, but each eclipse is always different. The corona, the atmosphere of the sun, this pearly white corona is always different. These are amazing events, and I hope if you have not seen one, please add it to your bucket list before you leave this planet. So partial eclipses, this is the beginning phases of an annular. This was the last annular eclipse I saw in 2012, just days before our 30th anniversary. And here it is, this annulus, this ring of fire. This was observed in Utah, like I said, in 2012, and it was setting. So we watched a sunset eclipse. And this is just a little sequence here using a wider angle lens of the annular eclipse. So the next annular eclipse, if you want to see one, now it's a bit far from Sunshine Coast, but if there's other people logged on from more Western or Central Canada, you might get to see this eclipse a lot easier, as there's an annular eclipse June 10th. And if I get my laser pointer here, starting in northwestern Ontario, going across Hudson's Bay up into the Arctic. So not the easiest place to get to. If you know anyone with a bush plane, can land here at Polar Bear Provincial Park. I think there's an airstrip there, but there are some roads with some lakes. This is an early morning, almost a sunrise event. So you need clear skies to the horizon, and that's coming up soon. This map is provided by Xavier Hubert, who's just an amazing eclipse chaser and has this page of, if you're looking for eclipse maps, he's got some amazing detailed maps for planning purposes. Okay, the last solar eclipse that I saw. So we're going to change from an annular now to the total. And this one is, now annulars are good, but they're not as exciting as a total solar eclipse where basically daylight turns to twilight. This one here, 2017, basically started in Oregon, went all the way across to South Carolina. Our family drove to Rexburg, Idaho, and took up residence, and I think it just was a farmer's field that they turned into a campground, but it was okay. The eclipse fever was setting in the local area. They were using, I think, pop cans here to make a crescent sun with the moon. There's the year, I think those are Coca-Cola boxes or something. That might be Pepsi, I don't know. Anyways, making Eclipse 2017 out of boxes, pretty cool. This is where we stayed for the eclipse. And there's always drama. I mean, there's always clouds the day before or hours before. There was this band of cloud passing through the area that had us all kind of nervous and worried. But lo and behold, the eclipse started and we were in the right place, right time. And you can do weird things. You can have, or fun things. You can take a piece of cardboard, use a pin, make a pinhole sign, and those are all crescent suns projected onto the cloth of a chair. You can use a colander, do the same thing. And here's, darkness or sort of daylight turning into twilight. Just an incredible experience. And, you know, using a telephoto lens or a telescope, you can see the red prominences jumping off the surface of the sun. Longer exposure show you more of the inner corona, longer exposure show you the outer corona. This is the atmosphere of the sun projecting out into space. And then before you know it, it's all over. This is a video. I'm just going to play a short bit of it. Just I hope you can hear the sounds. I get goosebumps every time I hear it. It's just so exciting to be standing there under the shadow of the moon. And you could see that glow on the horizon. I also did something different. For the first time, I took a can, cut off the top, put some photographic paper in there, sealed it up, and punched a pinhole in it and just let it, sit on I think I duct taped it to a fence post and let it run for 8 hours. And this is the path of the rising sun. There's totality, and then coming out of totality. Whoops. Okay. And of course, there's always a good excuse to drink some cheap champagne and celebrate the success and take the group picture of some Canadians that were down in, this was not a group led, it was just a family vacation, but we, met some other Canadians down there. Now, because this is happening on the surface of the Earth, the International Space Station was passing over the US, and low on the horizon, they could see the shadow. So this is a picture of the shadow of the moon taken from the International Space Station. Very cool. So again, this is a great way. I hope you get to consider chasing these moon excursions to stand in the shadow of the moon. It's a great way to meet friends and see the world. There's an eclipse actually happening on Monday, a total solar eclipse in South America, crossing Chile and Argentina. I don't think that, I know there's a few people trying to head down, but they're having difficulty. Flights are being canceled, COVID restrictions in cities. But there are a few people going down, and there will be webcasts, I think maybe in Spanish on NASA TV, but check it out Monday morning. The next eclipse for us here in North America, not too far away, is April 8th, 2024. The shadow of the moon will cross Mexico, Texas, right across the US into southern Ontario, Quebec, and into the Maritimes. So you wonder why we travel the world to see eclipses. Why? I mean, it's because you have to. You look at Fredericton here, at Fredericton, they get to see an eclipse in 2024. That's not too bad. That's just a few years from now. For me here in Calgary, I'm going to have to hang in for a few years, but 2044, if you're in Edmonton or Calgary, that's when the next eclipse here. Now, Sunshine Coast, you guys are not too far from Vancouver, right? Well, 2771 is when the next eclipse will be going through Vancouver area. So it's you got a bit of a wait coming in your hand there to wait for the next total solar eclipse there. So I'm just going to end. I cannot end this presentation without talking about a very rare planetary alignment. We have Jupiter and Saturn approaching each other. This was taken this summer when they were many degrees apart. Tonight, I had cloudy skies, so here's a computer-generated map. The Jupiter and Saturn are about a degree apart now. And on December 21st, right after sunset, look low to the southwest, and these two planets will almost appear to be like one single planet. They're so close together. And the last time they were this close, I mean, these great conjunctions occur about every 20 years. The last one in May of 2000, I don't remember because the two planets were too close to the sun to be seen. So I don't remember that one. To get another event that was this close in the sky, you have to go back to 1623, the time of Galileo. The telescope was just invented right around 1610 or so. But again, it was too close to the sun. The next time that these were this close, you have to go back to March 4th, 1226. This was the medieval period. This is Genghis Khan was, conquering China and Russia. I mean, this is how far back you have. This is a rare event is what I'm trying to tell you. So try to see this. If it's cloudy on the 21st, 22nd, I mean, try to see this event. It is rare. And if you miss this one, the next one that's this good is not until 2080. So, really make an effort. Also, there will be a landing back here on Earth, another re-entry over the Mongolian desert. China's bringing back the first lunar samples from the surface since 1976, so that'll be exciting. And I don't know if anyone saw this test flight, but oh my, I thought this was computer animation when I first saw it. But SpaceX is testing their Starship and they almost nailed it perfectly. Just the landing was a little too fast. Apparently there was a pressure breach and it lost pressure. But anyways, unbelievable. And of course, February 18th, Perseverance and Ingenuity will land on Mars along with a Chinese lander and rover, as well as United Arab Emirates orbiter. So there's lots going on Mars in February. So stay tuned. Ingenuity is really the first drone to fly on Mars. That'll be cool. So October 31st, will the James Webb Space Telescope finally be launched? I hope so. Canada is a partner. We built the Fine Guidance Sensor. So let's hope that it does launch and we get some more clues to the origin of our universe. So in summary tonight, watch a meteor shower. It's fun. You never know what you might see. And if you see a fireball, please report it. Volunteer for searching for meteorites. They're fun, COVID safe, and space rocks are cool. I hope you agree with me on that. Observe an artificial fireball. There's going to be one in 2023. And add a total solar eclipse to your bucket list, please. And try to observe that great conjunction that's coming up in just about 10 days from now. 2021 promises to be another exciting year. So I just want to thank you so much for this opportunity to share some of my stories. I'm also keen to hear your stories about first eclipses or looking for meteorites. It's always fun. And I'm now going to turn it back to I guess I'll stop sharing here and turn it back to our chairperson here.
Thank you, Don. Very quickly, one of the things that people asked while you were doing a presentation is, can I be a member of this group, please? Yes. You can join the RASC, absolutely. We'd love to have you do that. Please contact us at info@coastastronomy.ca. We can tell you more about it. But the first question that came up was when you were talking about the Hayabusa spacecraft, and the question from Peter Brackett was, did the asteroid's trajectory change as a result of the visit at all?
It wasn't a large enough impact to make that change. There is a mission that will be launched called DART. It'll be launched, I think, next year, 2021, about that. So it's going to approach a double asteroid, so a large one with a smaller moon, and they're going to fire a projectile at the smaller moon to see what it will do. So that's going to be exciting to see the results of that. Will it change its trajectory? These are things we need to know from that security. Part of OSIRIS-REx is security. Can we determine if we can actually divert or change the trajectory of an asteroid that might be headed to Earth, or will it fragment? Like, what will happen? This is exciting information. We need to know this.
Okay, the next question was from Don York, and he says, can Don talk a bit about the debris that just came down through Toronto recently, like how they determined where the debris came from?
Okay, and I really don't know enough about that. I thought it was more over New York. I'm not sure. I know there was photos of a fireball over Toronto, but I honestly don't know enough about that. So a good question, and I'd like to know more about it too, but I'm on the other side of the continent, sorry.
James, one of our members here, threw in Google Concorde's eclipse flight for an amazing story of eclipse chasing. And Richard Corbett threw in, just wanted to mention the most amazing thing about the Barringer meteorite in Arizona is just how close it landed to the visitor center.
Good one. Great question or great comment.
Does anyone else have any questions? You can unmute and ask, I guess.
I have a question. Yeah, Don. Yeah. So, okay, I get it that you've got all these this information to plot roughly where a meteorite might have landed. but I'm guessing it's still a fairly general area we're talking about. And apart from like seeing a great huge black splot in the middle of a pond, how do you really find one of these little fragments? I mean, just, you know, is there anything that you're looking for other than just, oh, there's a little rock that looks like a meteorite, or what do you do?
Oh, that's a great question because, yeah, especially when you're hunting in the mountains where there's rocks everywhere. There's a lot of rocks out there. And I mean, I saw enough elk droppings and other things that looked like meteorites on when I was hunting in near the Fairmont Hot Springs. Or every time I saw a little elk dropping, I got really excited. But what we use are rare earth magnets. Most meteorites have some metal in them, and they are magnetic. So if you put a rare earth magnet at the end of a stick and just start, you know, looking for, I mean, these rocks do have, if they're fresh, they'll have a nice black fusion crust. You might see some flow lines on that fusion crust. So it's not just, you know, they won't be typically rounded like a rounded boulder you might find here that had some water influence. Meteorites have, you know, sometimes an aerodynamic shape. There's things that you look for. I mean, we've done hunting, we kind of know what we're looking for, but the magnet on a stick, unless it's a carbonaceous chondrite, it looks like a piece of charcoal that someone took a hammer and crushed up. Those are very rare and very hard to find. Tagish Lake up in northern BC, that's a rare find. Good question, thanks.
Don, have you tried looking in the silt that gets washed off our roofs and then searching with a magnet?
Yes, I have. I do have a roof that you know has a lot of silt that comes off the roof, and I have not been like. I hear those fragments can be very small, almost you know, micron size kind of thing. I think I need a scanning electron microscope to see these. So to find larger fragments, you have to go through the roof technique. I think is for very tiny. I've tried, honestly, I've tried, and I have not been successful yet.
Don? Stephen Morris here.
Oh,
Excellent talk.
Steve. Oh,
Yeah,
Stephen.
here. Hello. There was an article in Sky and Telescope magazine about 5 years ago about someone who looked for micrometeorites in the eaves of houses, and he reported some success. And then a few months afterwards, there was a letter to the editor saying, no, I think that was not what you were finding. And so I think it remains literally up in the air. So you may find some magnetic stuff up there, but take a grain of salt with it, because the last thing I'd heard was that it was a very iffy proposition.
Yeah. Thanks, Stephen. That's a great point. And yeah, I mean, how are you going to, you need a very good microscope to kind of, does it look meteoritic, I guess, in origin? But that's a great comment. Thank you. And I just saw Alan. Yeah, I just saw Alan's pop up.
Yeah,
there.
he's got a question for you there. What do you think your next total solar eclipse would be? Australia 2023 or 2024 year?
Well, thanks, Alan. It's certainly not going to be Antarctica. If COVID is over, I'd love to go to Australia in 2023, but I mean, 2024 is a given, you know, provided good health and we can travel again. That's a for sure. 2023, I'm hoping we can travel again, Alan. Thanks. I mean, how about you? Is anyone else traveling to Australia?
Don, welcome from Utah, Osiris Rex country. I hope to go to Australia, and you made a great talk, and it was, I met you on a near solar total eclipse, which was almost an annular total in Atlanta, Georgia in 1984.
Yes, this is Ron, isn't it?
Yes.
Hi, Ron. Good to hear your voice.
Oh, great to hear yours. You did a wonderful performance tonight. I loved every bit of it.
Thanks, Ron. Yeah, we had a good one back in '84. That was great.
It was.
Thank you.
I have to tell you, Don, we had somebody that brought a rather large rock to our center thinking it was a meteor, and it definitely wasn't. So when we told him that, he said, well, it's leverite then. And I went, leverite? He says, yeah, leverite there, it's worthless.
Yeah, we get lots of meteor wrongs, as we call them, not meteorites, but meteor wrongs. And we have people that just don't believe us. You're wrong. It is a meteorite, and they just don't believe us, unfortunately. But yeah, it's rare.
All right, well, I think we've run out of questions. That was a fabulous presentation. Thank you very much, Don. We'll turn it over, Don York, we'll turn it